This is an excerpt from a conversation with Emil Jacobs, Yuan Lee, and Nathan Lewis, moderated by Andrew Revkin, brought to you by the Chemical Heritage Foundation's annual T.T. Chow Symposium.
Well, earlier you said we're going to have this huge gap between solar, like clean energy and solar energy. Between that gap, how can we reduce CO2 emissions from the energy that we have right now in order to, take the parts per million down before we get to that 450?
This is a great question. And again, I would include, if anyone wants to dive in, the direct capture of CO2 from the atmosphere as well as like carbon capture at a power plant. Do you see this as playing a realistic role anytime soon? Maybe we'll start there.
All right. I think you pointed to a very good place to start, and that would be what can we do to capture CO2 from coal-based power plants? In certain parts of the world, China being the best example, that is their primary energy resource is coal. And they are building many coal-based power plants. My numbers say they're building one world-scale coal-based power plant per week. That is a huge amount of power, and that's a huge amount of coal being consumed, spewing out CO2 emissions. So a good place to start in capturing CO2 is on large stationary sources like power plants. And I would argue that you can use CO2 capture on coal-based power plants for sure, and also on natural gas-based power plants. And the advantage there is you've got all of the material you want to capture in one spot and it's not moving around. So capturing CO2 at a power plant is one of the first places you would go. The next place to go is it's easy to calculate the cost of capturing CO2 at various sources. So what's the cost of CO2 capture at a power plant? Cost of CO2 capture on an automobile? Cost of CO2 capture from a manufacturing facility? And you can line these up and take the lowest cost at the top and the highest cost at the bottom and start working your way through putting in place low-cost CO2 capture facilities. You then have the issue of transporting it, which is pretty simple. Then you have the issues of how you store it. Now, for CO2 capture and storage, there's two tricks to making this successful. The first is low-cost CO2 capture. Right now, the cost to capture CO2 is relatively high, and we need technology improvements to lower the cost of CO2 capture. The other improvement you need is clear understanding of who has the liability for CO2 which you store underground. Is that a company's responsibility? Should be early on, but is it a company's responsibility forever? Or is it a federal government's responsibility or a country's responsibility at some point? So to make CO2 capture and storage really work, you need to get the cost down on CO2 capture, and you need to be clear on who owns the liability for the storage piece. But it's very simple to sit down and look at what's the cost to capture, go after the lowest cost pieces first, and work your way down that seriatim.
Which gets at this, that gets at the same question that was raised by the young woman earlier about externalized cost and where does responsibility or who pays the cost essentially is an interesting question. And the other big question, well, which is with all of these technologies, is scale. Can you do this at a scale the atmosphere would notice? I know Vaclav Smil is an energy expert I consult with a lot, says scale makes this a complete pipe dream, so to speak. I don't know whether Nate or Dr. Lee want to weigh in on carbon capture.
Andy, real quick, we have just a few more moments with Nate. So
oh yeah, right.
I was going to have everybody thank him for joining us from California. Do you have time for one more question?
Nate, do you want to weigh in on that issue of carbon capture playing a meaningful role?
Me? Sure. I agree that there are two things that we really need to do. One is it's nice if we could lower the cost of capturing the CO2, but it is imperative that we have confidence that it actually works. And what works means is when you bury amount of liquid CO2 that's equivalent in volume to all the water in Lake Superior every year below the ground, that less than 1% of it leaks for 1,000 years. Because if 1% of it leaks for 100 years, then when you're done, the same amount is leaking as when you started in the first place. So we have to have computational models and sensors and confidence that if we do this, that we're not spinning our wheels and we're just putting our heads in the sand. It's something that we really should be checking out technically, because it takes a big card off the table if we decide we can't do it. In the same way that we might decide, either for technical or policy reasons, that we don't want to build thousands of nuclear power plants. And if you take that big card off the table, you've taken 2 of the big 3 face cards away, and you've really only left then renewables. And there we have to figure out how to lower the cost, store energy, and build a system around them. So I think we need to work on all of those options, because we can't afford to fail.